Okay, hi guys. This is just going to be a short tutorial on inheritance in Java. Um, so I'm making a few assumptions here. One of them being that you already know the basics of Java, that being, classes, methods, encapsulation, so that's public, private, um, and that you're like aware of signatures. What I mean by that is if you just look at this class for a second, don't worry too much about what's going on. Um, that you know that you can have, so signatures is when you have like a bank system, right? And it takes an argument. That's one signature. And then you have another bank system constructor. So these are constructors, right? It has a different signature. And based on the arguments you pass in, the Java will use the correct signature, right? So we'll match the signatures. So if you're creating a bank system, so these are constructors. So when you create a new object of a bank system class and you don't pass in arguments, it will use this constructor. And if you do pass in a string argument, it will match, this signature, and it will use this constructor. So just in case you maybe didn't know about that, just a short revision here. Okay, so this is on inheritance, which is actually a fairly big topic, though the concept behind it is quite simple, and it doesn't look like there's much to it, but trust me, there is actually a lot. And we'll be just scraping the surface here. So just be aware of that. I'll cover a lot here, at least like for what you guys need to know, but there's actually like much more there to explore and learn about. Okay, so some theory first. So I found this diagram online, and let's not worry too much about the actual, like, what actually is going on in the blue boxes. Let's just try to understand the context of what's going on. So we can see we have three classes, right? We have a main class, we have an animal class, and we have a dog class. Now we are told that animal is a superclass and that dog is a subclass, right? So that means that that means that dog inherits from animal. So essentially, dog extends the superclass of animal. And that's what makes it a superclass. So in the main class, which is our starting point, we can see that our dog object, so we're making an assumption that we've instantiated a dog1 object somewhere above. We can not only call the bark method, right, that belongs to the dog subclass, we can also call its parents methods, which are sleep and eat. So essentially, and now, like, if you think about inheritance, it's like, heavily based on genetics. When you have children, your children inherit some of your traits, be it hair color, be it eye color. In object-oriented programming, the concept of inheritance is very much the same. So we have a parent class, or superclass as they call it here, which is the animal class, and it has some methods, it has some behaviors, and then we create a child of that class, which is the dog class, right? And it inherits all of the methods and properties of its parent. So I hope that makes sense. So as I said, this is a fairly easy concept. There's nothing difficult going on here, right? But once you put it in code, there's actually a lot of things you can do in code that leverage this inheritance and can change your code quite dramatically, but in a good way. Maybe not always, but most of the time. Right. So I created as an example here that I'll represent inheritance on. I tried to make it as simple as I could. So it doesn't resemble like real world scenarios, but it's purely for this tutorial just to show you how inheritance can be used. Right, so some context here first, right? So what we have here is a bank system. So whenever you have like a bank or like an organization, like a banking organization, right? They're going to have a bank system that will, manage all the transaction and withdrawals and deposits, right? But the thing is, you can perform these actions, transactions, deposits, etc., from not only the ATM, but also like your mobile app or your like branch office. When you like physically go to the branch of the bank, you can perform those actions there as well. So this is where we find our inheritance, because we have a bank system, which is like a parent. It's like the top system, top class, and then it gives all of these subclasses, which is our ATM, our bank branch, or like a mobile app, which I don't have here. These behaviors that are being inherited from the parent, so that they can also perform the same actions. So let's have a look here, what the bank system looks like, and just nothing too fancy, just a brief look at what's going on. There shouldn't be much to look at anyway. So we have a name. So this is like the only field, the only property of the bank system class that we have here. And don't worry too much about what abstract does just yet. I'll cover it at the end of the video, like what abstract actually does. For now, let's just purely focus on inheritance. So as I already mentioned, we have the name field, right? And we have two constructors. So one constructor will take no argument, and then for the name, it will use like a predefined string of bank system, and it will show us a message. And for the other one, we pass in the name as a string, and it will use this name that we've passed in as like the name of the object. So we'll assign it to the name of the object, and it will show us a message with that name. So for the methods, so as I mentioned before, a bank system should be able to transfer money, receive money, and withdraw. And do notice there's nothing fancy going on. We just print out a message saying some amount got transferred to some device, right? And then we call a receive on the device. So when we transfer from A to B, B being our device and A being, wherever we are here now, so like the object we're on, we want to take away the money from A and give it to B. So we say that we took the money away from A, and then we take the B object, our destination, and we say, okay, you receive this amount. And the receive method, do notice that this one is public, but the receive method is private. So we'll just say that, it receives some amount of money, nothing fancy. We're not keeping track of any balances. But this is private because we don't want the user to be able to invoke this method, quite obviously, right? We don't want the user to be able to receive any amount of money. That would be kind of stupid. So they're able to transfer money, they're able to withdraw it, but not receive, because it's private and it can only be invoked by the transfer method. So the withdraw method, it simply checks if the amount we're trying to withdraw is divisible by 10, and if it is divisible by 10, then we can withdraw. And if it's not divisible by 10, then we get a message that it has to be in increments of 10, the amount that we're trying to withdraw, and simply just return. And of course, a simple toString method that will show the name of our object. And some setters and getters, which are not really relevant. Right. So the next thing I want to look at is the bank branch. And this is where things get interesting. So pay attention. So in the bank branch, we can see that the class we have here, it extends the BankSystem class, right? So it inherits everything that's here, with exception of the receive method, I think. Not sure there. But we'll get back to that. It inherits all of this, and all of this is accessible from the bank branch. So now that the bank branch is a child of BankSystem, we can do a very interesting thing. And don't worry about the constructors just yet. I just want to show you something. So I've written some code here that I hope will be a good example. So as you can see here, we are creating a new bank branch, and keep in mind that the bank branch, it extends the BankSystem. So the BankSystem is the parent class, and the bank branch is a child class, right? It's a child of the BankSystem. And because it's a child of the BankSystem, we can use the BankSystem as a type to store it in. So branch A is just the name of our variable, right? But the type of this variable that we're storing this new object in is BankSystem. So it's the parent of the bank branch. And obviously, I mean, there's nothing stopping us from, just using bank branch as is. You can do this. So then the bank branch, it's stored in bank branch. That's perfectly okay, because you're storing a child of BankSystem in the type of itself. But we actually want to do BankSystem, and why we want to do this, I'll show you shortly, okay? So let's have a look at the constructors that we've set up here. And there's, as you can see on line 7, there's this new keyword called super, right? So let's just think about how constructors work, right? The way constructors work is they are called when we create a new instance, a new object of the class. So when we're creating a new bank branch here, right, it will call one of these constructors. And remember, we're matching signatures. So the signature here is the string name, and we do pass in a string here. So in this scenario, right, it will use this signature. So it will invoke this, it will invoke the constructor of this signature. The problem is, we want to use this behavior from BankSystem, right? We already have a constructor with the same signature. I mean, yes, it has a different name, but notice like the signature is the same. And rather than write it here, then it's better for us to write in the parent class, because then when we have more children of the parent class, so right now we have bank branch and ATM. Imagine we have a mobile app and I don't know, email and whatever else. We have to write this in every one of these constructors. So it's much easier for us to write it once in the parent constructor, and then simply extend the child class. And here's how we invoke it. So once we create the object, it will look for the proper constructor. Once it finds it, it will execute it. Now, if we omit the super keyword, right? By default, when we're extending classes and there's a super keyword missing, it will by default just use the empty one, the default constructor, right? The one that matches the empty signature. So obviously, if we remove it, I don't think it will run any constructor. So now that we've removed this, will it? No, it actually says there's no default constructor available in BankSystem. As you can see, even though we're missing the super keyword, just like a keyword that invokes our constructors here. Maybe I actually didn't explain that. I'll get to that. Just keep in mind that this is the default constructor. So if there's no super keyword, the constructor that we invoked here, kind of implicitly, it's not explicit, we're implicitly invoking the default constructor here. So what happens is when we run this code, you can see that we get this message, the BankSystem is online. So that's the message that we have here in the BankSystem in our default constructor, right? The exact same message. So what happened is we match this signature we run this constructor. Obviously, it's empty and there is no super keyword. So Java went, okay, let's have a look at the default of whatever you're extending, and it ran this. I mean, it would run this even if we had something here. It doesn't matter. The idea is we're missing the super keyword. So now we will get 2 messages, right? There you go. So actually, do notice that super is being invoked before the message, even though it's missing, right? It's missing. So even before it runs this constructor, it defaults to this one. So this is how actually things are supposed to be done. And I'll explain this now. So what super does, it essentially calls the constructor of our parent class. So this super, brackets name is essentially a call or an invocation of the constructor in our parent class. So before we were, when super is missing, it defaults to this kind of signature, an empty one. So that's why we were running this. But now that we've created super and wrong class. Now that we've created the super method and we pass in the argument that we receive from creation of this bank branch, right? This matches this new object when we create it. It matches this signature, so it runs this. And because we already have super, defined explicitly, Java won't do anything implicit. It will instead look at the super, right? At the super method. It will look at its signature. So we'll see, okay, we're using name, which is a string. Do we have a constructor here that matches this kind of signature? And yes, we do. So it will now use this this constructor. And you always want super to be the first thing in your constructor. If you're doing it any other way around, you're not doing it right. So now you can see where we have a string here, which is branch A, right? We pass it in here. We match the signature of this constructor. We take it as an argument. Then we pass it in further to our super method, which invokes the constructor that matches the signature, which is this one, right? And then we use the name to print this message, and that's what we get. We get the branch A is online, so it matches this argument, and obviously we get hello. I wonder if I put this above. Yes, so we get a warning here, or rather, actually, it's not a warning; it's an error. It says, call to super must be first statement in constructor body. Okay, so in here it's empty, but essentially this empty constructor is the same thing as just implicit, explicitly defining an empty super, right? So this and this is identical. It just, when we don't put the super method and we're extending class, it's implicit. So it's not, we're not telling anyone, but it still happens. We're not telling anyone that we're calling this constructor, but Java still makes it happen, right? So whether you want to put in empty supers or whether you want to make it like implicit is up to you. Personally, I think do this. It's explicit. It's clear. Especially for beginners. Maybe senior developers would disagree with me. But I'm just, I really want you to remember that even if you don't put in the super keyword, the super method, sorry, it will still call the default constructor in the bank system. That's something to be careful of, right? So you can see we have another line of code here. This time we're not putting in any arguments. So it uses the default constructor, the empty one, right? But we still get the message, and that's because we call the default constructor here, whose name defaults to just BankSystem, right? So that's what I was talking about, that kind of implicit super call. Okay, enough about this. Let's move on to more interesting things. So let's have a look at the ATM class. So I think ATM class is very similar to the bank branch class, right? you can see is very similar layout, except this time when we match the empty constructor signature, what we want to do instead is we want to call super with a argument, with a string argument in it. And this string argument is not a variable, it's actual string, it's actual hard-coded string. That is because when we create a new ATM, like we are doing here, right? And it's empty, we don't want to default to this name. We want to default to this name. So essentially what we're doing here, even though, this is a different signature from this one, we're going to use this constructor to change our default name. So that's actually pretty handy. And then, so both of these cases here, they use the same constructor, which is the second constructor in the bank system. So that even when, we instantiate new ATM that is empty, you can see that we get, for the name, we get ATMs online. We don't get bank systems online, we get ATMs online. And for the ATMA, obviously we use the second constructor here, and we just pass in the name as an argument rather than hard coding it. So we get the argument that we passed in, which is ATMA. But I don't know if you've noticed, but there is something awkward going on here, right? So we have branches and ATM, but they're both the same type. They're a bank system type. They're being stored in a variable that's a bank system type. That is what I was talking about before. Even though these classes are essentially different, right? They're different names, so they're different types. We're still storing them under a common single type because they're both children of the bank system. So we can, since they're both children, they kind of both belong to it. We can store them under this common type. And obviously nothing is stopping us from just storing ATM and ATM. That's also perfectly valid. But why would you? Right, so let's move on. So what do we have here? Let's comment this. We have some print messages. We're just getting these names again. So this is where we're using the toString method. So you can see that all of these objects, they inherit the toString method. So we get the same message and obviously different names. So you get, this is branch A, this is bank system, this is ATM A, and this is ATM. So this toString method is available to all of the children of bank system, which is bank, branch, and ATM, which we're calling here, right? So remember, when we print an object, it will look for the toString method, and that's the method here. Now we're going to get into kind of more difficult things. I'll try my best to make as much sense as I can. It's not always easy to explain things, so forgive me if I get a little bit sidetracked or convoluted here. Right. So I mentioned the three methods that we have, right? One for transferring, receiving, and withdrawing. So the way we want it to work is we want to transfer from one device to another device. So we're not really concerned about the users exactly. Without extra complexity to this simple example. So I opted out for something simpler. So we're just essentially transferring, for example, money from branch A to branch B. So the way we do it is we call the transfer method on branch A, and then we specify destination and amount. But do notice that even though branch B is a bank branch, and ATM A is an ATM, we can still use the same method, right? And no, I don't have two methods specified here, just one method. The reason for this is, again, is because BankSystem here, that is the argument, the type of the argument, is our kind of common type of a variable. Because both ATM and bank branch are children of the bank system, they can use the same type to be stored in. So obviously you could do something like this, I think. And sorry, it's supposed to be bank branch. And then you need to make this public. Right? And is it going to work? Oh yeah, and then you also need to make these from BankSystem into so what's that? Branch A and B. So I think this needs to be bank branch, and this needs to be ATM, and this needs to be a bank branch again. Now it should work. You know, so like this will also work, but now you have two transfer methods, and you know they do the same thing. I mean, you could define another private method and just have these called the private one, but it's just getting too complicated, right? So it makes much more sense to have this common type. And let me change things here as well. I hope I didn't change too much. Okay. We are back to where we were at the beginning. This is much simpler. We're just saying, you know, accept any children of BankSystem or the parent as well, because you know the parent could be also accepted. If you create a BankSystem object, you could, you know, it's still a BankSystem. So any parent or children of the BankSystem, and then simply transfer the amount to device.getName. So device is our destination. So we're just calling the getName method that's down here to get the name of our destination. And then we're calling receive on the destination. So we transfer the money out of our source, and then we want to receive the money at our destination. And the receive method simply just takes in an amount, prints a message. So this is where our, you know, inheritance in this kind of a common type come into play, just making it much easier to, you know, create methods that apply to kind of a certain group of classes. So let's just see this in action. Okay, what do we get here? Let's zoom in a little bit. So we transfer from branch A to branch B. We transfer 100 euros. So we transfer and then we receive from BankSystem. Or sorry, the BankSystem receives 100. So branch B gets like the default name because this is empty. So we're transferring 100 to BankSystem from bank A, and then the BankSystem receives 100. The first case. The second case is the ATM A. So branch A sends money to ATM A, so we get transferred 55 euro to ATM A, and then we also receive the money. So ATM A received 55 euro. Now in retrospective, I think it would also make sense to put in the source of the money. So transfer euro from, you know, what's this? Branch A to ATM A. So you could do that as well. Maybe do it as an exercise. But yeah, this also works. And then the last case is we simply withdraw money from branch B and branch B and ATM B. So that's everything for inheritance. I'll just want to cover one more thing here. As I mentioned this abstract keyword before, right? So what abstract means is we cannot instantiate the class that is an abstract class, right? We cannot create new objects of it. So if we go to our main file here, where our program runs, if I try to create, you know, BankSystem, call it BK, is equal to new BankSystem, it's going to throw an error, and the error says BankSystem is abstract, cannot be instantiated. Obviously, nothing is stopping us from just removing this keyword, and all of the inheritance, it still works. It still works just fine. The only change is that now we can instantiate the BankSystem as an object, and obviously it has still all the methods. So BK, we can transfer money from the BankSystem to branch B or branch A. We can run it, and we get the transfer. Format it a bit better, more obvious. There we go. So transferred €100 to branch A. So this is what we do here. So this also works, but we don't really want BankSystem to perform these operations, at least not in this case. So I made it abstract, because the BankSystem, it doesn't really, it shouldn't really be an object. It just should kind of be a parent for all other objects, right? So if you wanted to have like some place where you distribute all the money from to all the branches and ATM, I would do another class. I'd call it, for example, money source, right? And then you do BankSystem source is equal to new, money source, or vault, for example, vault. And then you can transfer all the money from the vault to, call this vault as well. You could transfer it to all the branches. So branch A. Actually, you have to do it afterwards because branch A doesn't exist there yet. Something like this. Obviously, I'm getting an error here because I don't have a vault class defined, but you could do it. Obviously, the vault class would have to extend the BankSystem, right? That's how I would do that. And I think that's all. Good job if you managed to watch all of this video, and if you understand what's going on. If you don't, just leave a comment on. I'll try to respond to it, and I'll see you whenever.